Hello everybody and welcome back to the DCAC channel, and today we're going to be solving another Leetcode question. Unique email addresses. That sounds interesting. Ooh, that's a long description, so let's go for it. 929 unique email addresses or addresses. Every email address or every email consists of a local name and a domain name, separated by the @ sign. So we are still kind of, I think, in the web domain of problems. At least, I mean, yeah, you can kind of see it in that way. We're still going to be talking about domain names, local names, stuff like that. For example, in alice@leetcode.com, Alice is the local name, leetcode.com is the domain name. Besides lowercase letters, these emails may contain dots or pluses. If you add periods, dots, periods, between name characters in the local name part of an email address, mail sent there will be forwarded to the same address without dots in the local name. Okay? So if you have these type of characters or dots between some characters in the email, mail will be sent or will be forwarded to the same address without dots in the local name. Example, alice.z would be alice.z, or at least they will forward to the same email. That's interesting, I didn't know that. Note that this rule does not apply for domain names. Okay. So if you add a plus in the local name, everything after the plus sign will be ignored. This allows certain emails to be filtered. For example, m.y plus name @email.com will be forwarded to my@email.com. Again, this rule does not apply for domain names, so we are only stating rules for this part. At least for now, this part is just symbolic, okay, domain name. It is possible to use both of these rules at the same time, as we can see here, I guess. Given a list of emails, and our emails are strings, we send one email to each address in the list. How many different addresses actually receive emails? We send one email to each of those addresses. So we basically have to see, for example, let's see, in our example, we have test.email plus alex@leetcode.com, test.e.mail plus bob.cathy@leetcode.com. Then we have test email, the same, plus david@leet.code.com. So for example, this one should be different than this one and this one, because we are differentiating between distinct domain names, right? For example, the dots and everything else, I guess. But for example, test email and test email without the dots and everything ignored after the plus will result in the same email exactly. This one will be different though because of the domain, which would be this one, right? This one is this, these two are this. Output 2. So we only count, I guess. Let's see our constraints. The list or the length of the list is maximum of 100, minimum of 1. So we're not dealing with empty lists. The length of each email address is at minimum 1, at maximum 100. So at minimum 1 would mean we will be probably just getting something like this, right? That is kind of crucial. Each email contains exactly one @ character, which is also good. So we can kind of split on the @ character and kind of handle both sides on left and right of the @ character separately. All local and domain names are non-empty. Yeah, but like if you have all of them being not non-empty, but the length of each email being at minimum 1, you cannot have anything more than, for example, I don't know, like A, is this the local part or the domain, right? You cannot have it as both parts. Also, like separator is always there. So basically these two parts will be empty for an entry that's size 1. I think somebody messed with the constraints. At least logically, I don't see why not. Is this the case? But yeah, sure. And local names do not start with a plus character. I guess it's good. Yeah, it's good for comparison reasons to kind of know this. Okay. How would we actually go with that? So first of all, we want to see how many, right? We want to see how many domains we are dealing with. The domains are, well, to be exact, what we could do is we could actually work with the first part, right? Kind of like clean that up. For example, ignore the dots, ignore the pluses. Exactly here the same. And then we can just attach basically the cleaned up part to each of those later parts, right? So basically everything after the add and domain will be added to the cleaned up part, which in this case, in both cases would be this. And in each case, so we go over each element at a time. After we clean it up and attach the add domain, we can basically map it again into a dictionary and just increase the amount of well, actually, we're not even going to be increasing the dictionary. We're just going to be looking if that dictionary contains that element. If it doesn't contain it, we'll add it. And at the end, we're just going to count how many entries we have in our dictionary. So why do I do this instead of a list? It's because now we know, at least from the kind of like previous episodes, we know how to work with dictionaries, and they will be way faster by comparison. Otherwise, I will have to kind of loop through the array if I'm going to be collecting this in an array. And yeah, runtime is way better in this case. We'll be getting constant runtime for updates into the dictionary and lookups into the dictionary. So this will be the better choice, I guess. So we'll call our dictionary unique emails or unique recipients, and it will be an empty dictionary. And now we go, I don't know if a recipient is called, I guess it's spelled like that. All right, for email in emails, and we know it's a list of strings, right? We'll say local domain our email dot split on the add symbol, right? So we get both of those parts. And now we know that anything containing a dot or a plus should be discarded. How can we do that? We could literally just say local cleaned, and we can basically do the local on split. If we split the local, in this case I'll be using, whoops, this type of parenthesis. Oh yeah, parentheses, not parentheses, exclamation marks. I don't know, like these guys, the simple ones. If we split our local part on the dots, right, and we just do our usual join operation on what exactly is the resulting array after splitting here, and we join it, we should be getting, basically we remove, for example, if we had something like this, let's have an example. And I don't know, email me or address. So if we have our split here, we'll be having an array that contains basically all three separately. And if we join it, we should be getting test email address as a single string, right? And we can do the same operation again. So basically our result, we can directly split it again, right? And it's going to be a bit crowded here, but we kind of know what's happening, right? After we join our first split, we have a string, a single string that has no, what's it called, period separators. And now we can also, actually, we need to disregard. So actually we'll be doing, now we'll be splitting on the plus, but the first plus that we see, and we'll be getting the 0 index. What that does is basically, and I just quickly want to see if I'm recording. Yeah, I'm recording. So what that does is splitting on the plus sign, the very first plus sign that we see, because we know everything after a plus sign is to be ignored anyway, right? In this case, for example, the first operation would remove all these 3 dots. We'll keep the plus sign. If there was a theoretical plus sign here afterwards, it wouldn't matter, because we'll split on the first one. We'll get left side and everything after the first plus sign. And we'll disregard that, and we'll just keep the first part. And we don't even need to be joining anything, because after the split we'll be still left with a single string, because as we said, the left part will already have everything that will have dot delimiters disregarded, and everything will be joined in a single string. So splitting on the plus will leave us with a single string. We don't need to join anything. I hope that much of a description was enough to understand my way of thinking about this. I'm not sure still if that's going to work, but I think that we can now look for example, address, and I'll just create a separate variable. We can actually work with it here, but I don't think that's necessary right now. We'll do address cleaned, and this will be our local cleaned, right? And then we'll do join, I think was it, and then it will be, I guess, an add, and of course after the add we'll also add, as basically this operator leaves us a way for example, here we are creating a new string, right? And this is a placeholder, so we can do formatting on that placeholder, and in the placeholder we'll just put our domain. So this will basically create a string that contains the add symbol and everything that was in the domain beforehand. Okay, so here we already have our cleaned address, and now again, oh yes, I think it was like we need to access our dictionary now, right? So I think it was something like get, and now we are getting the address, the cleaned address, and if it doesn't find it, right, it should just add it. And this is how you'll do it. If it doesn't really find this entry, it will actually add it. And I think it will add it with basically with an empty value, but I don't think that will be wrong in this case. And in this case, now I think the only thing that we have left in this case would be, and there are a lot of ifs in this in this approach, so I think we'll need to debug a bit if things go wrong, but for now we already populated our recipients Oh, actually, that's not what we wanted. Sorry. We are not getting, because we don't really need any. Yeah, we are not getting the values from there. We only want to see to basically create this entry, and I'll create it with an empty value. I'm pretty sure we could probably do something better. I'll quickly Google it afterwards, but I just want to see this, just have it work for now, and I know this will work. So we'll basically create this entry. We'll have this key being created or updated. In the first case, it will be created. In the second case, it will be updated. And to always be updated with the same value, and we don't really care about the value, we only care about the keys. And how we would do this at the end is we only return the address, the unique recipients, the length of the keys of this dictionary, and these are basically all the unique addresses that we have gone through, because we will never create the same address twice in this dictionary. It will always be the same one if it existed. Like if we actually visit one of those emails, and all of those that we visit, we can then at the end basically print out as our result. So a lot of ifs. Let's see how things go here. Not defined. Recipients. Oh yeah, typo. Very first thing. I think it was the only typo though, at least for this one. And the answer is accepted. This leads me to believe that we actually did a good job, at least for now. Let's quickly check what would happen if we have something like, yeah, these constraints are a bit confusing, because now I'm not sure if I want to check for types where, for cases where there is nothing here on the left, for example, and on the right. But I have to check for cases where there is nothing on the left, right, and something on the right, and vice versa. So for example, let's see if we have something like @ and domain.com. What would happen here? We split, and we know this will basically be empty. This will be not empty. Here we will split again the empty on the dot. And actually, I'll just try it afterwards. We split on the dot. Basically, we get nothing, hopefully. There is a potentiality that here we get a problem, right? Because if we have a non-value and not an empty string, but I think we'll be getting an empty string. So the empty string getting splitted and added to an empty string will result in nothing. Getting splitted again on the plus sign will result in nothing. And if we get the 0 index, we'll be getting again the empty string. We can then add this empty string to the domain that we had, and we can add the domain. And the domain will be this one. So this should work. What will be... Oh, all local domains are non-empty. Yeah, in this case, I don't even know how yeah, I think we don't even need to check for those cases, right? There was a confusion about the requirements, but I don't think we even need to check for those cases, because they say there will be no empty stuff. And like we see, we actually got it. I think our runtime is again kind of influenced partially because the interpreter here sometimes runs differently. And also we are creating multiple variables, and we don't even need to do that. We can actually put everything into a single operation, right? Just, okay, the first one we need kind of to do. The second and the third one, we don't really need to separate, so we can basically put this whole part here. And for this one, there is nothing to improve, I guess. Yeah, I think our runtime is only, maybe my approach in this case is not the best, but I mean, I don't see anything wrong with it, to be honest with you. Our runtime, if we think about it, we are going over each element in the list. We are only doing the splits. And yeah, you can kind of think about it as you could have discarded, yeah, I can see it. We could discard the splits, the plus splits first, so we can then only do a lot less theoretically dot splits, right? Because everything after the first plus sign will be discarded. We're not going to be splitting afterwards. So this is a potential spot to improve, but I think, like I said, in our runtime analysis, not really that important. We are doing single operation. So again, we are having a well, theoretically there may be many splits. So this is a variable, but yeah, there may be many splits even before the plus sign. So we are doing n in the length of the emails. So for each email we go once. Then we have m in the amount of plus signs before the dot signs, I mean, before the plus. And basically we are splitting for each of those. So I'm not sure how that runs under the hood, but let's call it m. And yeah, the other stuff is basically single operations. So in runtime, we could be looking at some weird n times m runtime complexity, but I'm adopting out that actually. But yeah, you can correct me on that, because yeah, these are string operations, so maybe that's the case, right? You kind of have to look through the elements to kind of find. I'm not sure. And space complexity would be, well, we are taking a single string, we are creating a couple other strings, so it's basically linear. So yeah, I think that was our approach. I think it was pretty intuitive, although written, I'm pretty sure if you go back to the code at some later point, it will be confusing. Sometimes it is like that. And I haven't found any good solution to actually deal with these cases. Like simple functions that more or less are understandable and are very logical in their way, but only once you kind of go past the syntax. And in this case, I cannot really do much. Like the naming is already good. Syntax is just kind of messy, right? And yeah, if you guys have any suggestions, I would like to know what could be improved for such functions. Like I have this issue at work sometimes, and like I said, so far I don't have any solution for that. But anyway, good algorithm. I think it's worth checking out. Multiple concepts here already applied, so give it a try, and see you guys next time. Bye bye.